Hey there, happy Valentine's Day. I am sitting up here finishing up your lesson 7-2 assignment so that you can do over the break. All right. And yeah, I hope you enjoyed your Valentine's Day. We are doing some Carnegie learning. So we're going to talk about 7-2, which now deals with systems. In 7-1, we learned how to graph an inequality. Okay, so we learned a couple of things. We learned the difference between a problem written in slope y-intercept form and a problem written in standard form. Okay, and you have those notes hopefully, and if you don't, you can download them from the portal page. I have them there. You can just print them out, or you can copy them down. Either way will work. And we're dealing with systems of equations, which means we're dealing with more than one inequality. And of course, we still have to understand, are we writing it in slope intercept or standard form? So let's look at this. And when I look at it real quick, I see that Samuel is remodeling his basement. One part of the plan involves the flooring. He knows he's like both carpet and hardwood, but he's not sure how much of each he will use. The most amount of flooring area he can cover is 2,000 square feet. The carpet is $4.50 per square foot, and the hardwood is $8.25 per square foot. Both prices include labor costs. Samuel has a budget of $10,000 for the flooring. So write a system of inequalities that represents the maximum amount of flooring needed and the maximum amount of money he wants to spend. Okay, so the maximum of flooring. That means we have carpet, X plus Y, and it has to be less than or equal to how many feet. So remember, carpet is one of the things and hardwood is the other, X and Y. We have two independent variables. We know we're doing a system because we have two independent variables. We have two rates of change. Okay, so we know that X plus Y has to be less than or equal to 2,000 because this is all feet. Okay. And then we have $4 per foot, per, meaning this is our X, $4 per, which is our Y. Okay, so now we have 4.5x plus 8.25y has to be less than or equal to 10,000. Because this is money, money, and money. So those would be our two systems. All right. One idea Sam had was to make two rooms, one having 400 square foot of carpeting, so that means my X would be 400, and having 1,200 square feet of hardwood. Determine whether this amount of carpeting and hardwood are solutions for the system of the equation. Which means, will this answer be ooh, and I apologize. I made a mistake. It's not greater than or equal to 10,000. When you budget something, you have to be under the amount. So, there you go. That's what happens when Mr. Frazier goes fast. He's not paying attention. So a lot of times we have to double check and make sure that we're reading the question carefully. I make mistakes just like everybody else. So the important part is when I see that I've made a mistake, I make sure that I notate it. Read 2 times. So that means not only read it once, but after I tried to do the problem, now read it again and make sure it makes sense. And if I'd have read this twice, I would have said, okay, this amount and this amount has to be, less than or equal to 10,000 because 10,000 is the maximum amount. And guess where else I made that mistake? Correct. My square footage in my house has to be less than or equal to 2,000. My house isn't suddenly going to get bigger. right? This is as big as my house can be. So I'm supposed to be less than or equal to. So we'll do that there as well. I had them backwards. Okay, so making sure your inequalities start in the right direction. And it has to make sense. Can my house be bigger than 2,000 square feet? No. All right, so are those going to be solutions for this set? So one way of doing it is we go ahead and put in 4.5, and we put in for x 400 plus, and we put in 8.25, and it's 1,200 square feet. And now we do the math. Well, let's see if it works. That means we have to take out our calculator. Hopefully you have yours, and you do it. And you would see what the answer is. Okay? And you're going to tell me why. We'll move on. Now we're going to graph the system, which means we look at each inequality and graph it. Now they're in standard form. So we're going to do x-intercepts and y-intercepts. So the first one's pretty easy. The first line, x-intercept and the y-intercept, are both 2,000. Okay, so that makes it easy. They go 2, 4, 6. Let's see. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Yes, this is 20,000, and this is 250, 500, 250, 1,000, 250, 500, 250, 1,000. Okay, so they've counted by different amounts. So I had to figure out how they were counting. They counted this way, and then they counted this way. All right, so now I draw my line. The problem is this one's going to be solid, and hopefully you use a straight edge. I'm using a Spider-Man Valentine's Day card. Yay, Spidey. Okay, and I'm using a solid line only because I use the term equal to. When I use the term equal to in my problem, less than or equal to, I use a solid line. So that's my x plus y is less than or equal to 2,000. That's what that line looks like. Now I'm going to graph my other line. And I'm going to do x-intercept and y-intercept again, because I find that easy, which means I'd cover my x, and I get the y-intercept of 10,000 divided by 8.25, which gives me 12, which would be, in this case, right around here. Okay, because each one of my lines was 250. So I'm going to go up 2, but a little bit less because it's less than 250. Each line was 250, so I went 250, 500, another 250, which is 750, 1,000, so it's just under 1,250. Okay, and now I'm going to graph the y-intercept. So that means I put a 0 in for the x-intercept. I put a 0 in for y, and it's now 10,000 divided by 4.5, which would be 2,222. So now I look at the other line. It's 2,000, and if I'm going to go 222, that means I went out one more line. Uh-oh, look at that. I'm kind of off the graph. It's okay. I can be off the graph. Okay. So if I use the same units for both, I wouldn't be off the graph, but I didn't. Right, and hopefully you see where that intersection is. Here's the intersection. Now that intersection is our break-even point still. Oops, sorry. Our intersection is still that break-even point. Okay, the difference is going to be that break-even point only gives me where the profit would be or would not be. So now we put in our zeros and see where our shading is. You're going to want two different color highlighters. Two different color highlighters. So I'm going to try and do this with two different color highlighters. So my first line is 0 is less than 2,000. I put in my double zero. 0 is less than 2,000, which is true, which means my first line I would shade over here, right? That's my yellow shading. Fun, fun, fun. I get to color. Okay. This is my second line. Okay. This line right here is the second line I drew. And when I put my zeros in for this problem, I get 0 is less than 10,000, which means I'm also supposed to shade under this line. Now, hopefully, you using your powers of deductive reasoning, you have figured out that if I go ahead and extend this line, all of the answers that are under both will work. Now, here's the question. Do we really deal with any of these answers over here? Are these realistic answers in that section? And hopefully you know that those answers aren't realistic, and neither are these answers realistic. Why? Well, you can't have negative flooring, okay? You can only have a positive amount of flooring. Okay, but theoretically, that's where we're shading, everything below. And what the answer is will lie within this area right here. Okay, right in that area is where our answers could be. We've got multiple answers. We know for a fact we can't have an answer out here. All right, now if we want to know the exact intersection, this is where we do our systems of equations from equalities. So you have x plus y is less than or equal to 2,000. And then you would change, remember we're going to change that other problem, and it says 45x, because we're getting rid of the decimal, and actually it'd be 450x, plus 825y is less than or equal to, and we're adding how many decimal places? 2. So now this number is 1 million. Okay. And we're trying to make opposites. Okay, now this is a review from what we did in chapter 6. And if you don't remember, it's elimination. Now there's not enough room here for me to do all my work. So now I'm going to shift to another piece of paper. But this is the work. We got to get rid of the decimal, which we did by multiplying by 100. And now we have to make opposites. We're making opposites so that we can eliminate and find that middle answer. So here we are. X plus y is less than or equal to 2,000. And 450x plus 825y is less than or equal to 1 million. So now we got to transform the top. So I'm going to multiply all this by negative 450. So negative 450x plus negative 450y equals negative 900,000. This line was 450x plus 825y equals 1 million. And now I eliminate. And how do I eliminate? I eliminate by moving straight down. Okay? So, or adding straight down. So this eliminates, x is gone, and you're left with 825 minus 450, which is 375y, equals, then of course 1 million minus 900,000 is 100,000. How do I solve for y? Y is equal to, I divide both sides by 375. And my answer is 266.6. Repeating. Now, that means 266 square feet. Can you have parts of a square foot? Yes, you can. Now I have to solve for x. After I have this, I have to plug it back in. So, if y is 266.6, I have to figure out what x is. And this one becomes easy. Now, anybody want to tell me why I picked this problem and not this problem? Or these two problems? Because I can pick any problem. I pick the one with the easiest numbers. X plus y equals 2,000. So that means x would equal whatever 2,000 minus 266.6 is, which would be 1733.4. All right, so my break-even point is where I have 1,700 square feet of carpet and 200 square feet of wood. Okay, that would be the optimum. In other words, that maximizes the most square footage of wood and the most square footage of carpet I can do. All right. Good luck. And we'll work on 7-2 next week. Those of you who've got some extra time, work on 7-2 Carnegie. And you're going to get some crazy answers. I will tell you that when you get answers that have decimal places, only go to the 4th decimal place. All right? Only go to the 4th one. All right, guys. Have a good rest of the weekend. I'm going home to celebrate Valentine's Day. We'll see how well that goes over because I'm late. All right, we'll see you.